Hello and welcome. In this video, we want to find the Thevenin equivalence of this circuit through the terminals A and B. And in order to do that, we need two components: the open circuit voltage VTH and the equivalent resistance of the circuit when all the independent sources are turned off, RTH. Finding VTH is quite simple. First thing we want to do is we want to find the current in the circuit. Then after we know the current in the circuit, we connect a voltage source across it, and that will be VTH, and try to figure out the value of the voltage source. Okay, finding the current in the circuit, we can use mesh analysis. We call this the first mesh with the current I1, the second mesh with the current I2, and the third mesh with the current I3. And you notice that we have a branch containing a current source here, so these two meshes can be merged together into one super mesh. And from this branch, we can write the equation that I3 minus I2 equals 0.1. I3 minus I2 equals 0.1. You can call this our first equation. We can then write a KVL equation in this super mesh, and then let's say let's call the super mesh SM23, and that super mesh will have 26I2 plus 10I3, okay, plus 4I3 plus 15 into I3 minus I1 plus 40 into I2 minus I1, all equals 0. And with that, we can say that minus 55 I1 plus 66 I2 plus 29 I3 all equal 0, and we can call that our second equation. We can then proceed to the last mesh, which is mesh 1, M1, and write our equation there. We have 40 I1 minus I 40 I1 minus I2 plus 15 I1 minus I3 minus 17.4 minus 17.4 all equals 0. We can then say that 55 I1 minus 40 I2 minus 15 I3 equals 17.4. We can call this our third equation. We can then proceed to solving these equations simultaneously to get the value of I1, I2, and I3. And with this, we say that the value of I1 would be equals to 0.744 amperes. I2 would be equals to 0.4 amperes, and I3 would be equal to 0.5 amperes. The next thing to do is to connect a voltage source across the open circuit terminals, and that voltage source will be VTH. Then we can use this voltage source to write a KVL equation. So in a loop, so we can just pick this tiny loop here and write a KVL equation there. And we know that the current flowing in this direction is I3, which is 0.5 amperes. So we can say that VTH minus 10 into 0.5 equals 0. Then with that, we can say that VTH is equals to 5 volts. The next thing to do will be to find the value of RTH, which is the voltage, the resistance of the circuit through these terminals when we put off this voltage source and this current source. Now, putting off this voltage source will leave a short circuit, and putting off this current source will leave an open circuit. So we will end up with something like this. The voltage source shorted out and the current source cut off. Then the value of RTH should be what we will measure with an ohmmeter connected across A and B, which should be equals to, you see, we have these two resistors in series, so we say 40 plus 15, but then they are in parallel with a short circuit, so everything there in parallel with 0. Then we have this setup in series with this 4 ohm resistor and this 26 ohm. So we have plus 4 plus 26. Okay. Then everything would be in series with this 10 ohm, in parallel with this 10 ohm resistor. So in parallel with the 10 ohm resistor. So anything in parallel with 0 would be 0. Any resistance not in parallel with 0 will be 0 because that is a short circuit. So we'll be left with 30 in parallel with 10. And we would have 30 times 10 divided by 30 plus 10. And that would be equals to 7.5 ohms. And now we know that our VTH is 5 volts and our RTH is 7.5 ohms. We can draw our Thevenin equivalent, which would look something like this. A, B, we have plus minus, and we have 7.5 ohms here, and we have our 5 volts here, and this is the Thevenin equivalent of the circuit, of this circuit, when seen through the terminals A and B. And that will be all for today. Thank you for watching. Don't forget to hit the like button and subscribe. Bye.